Guys, welcome back to another video. Now, just like always, make sure that you have your bulb pen ready. So we are going to add the full bulb pen feedback. So full bulb pen as always, full explanation as always. Okay. Now the way we're going to do that is I'm going to tackle the written word question first. Okay, so question 1 is written. We're going to tackle this first. I'm going to show you how to answer this, and then the rest is pretty much calculations, and you should be able to find it from the asking. Now let's take a look here. So this here is specific capacity. Now if you remember, so from specific capacity we've got the equation of energy is equal to mass times specific capacity times change in temperature. Okay. And the question says, what measurements, okay, so state the measurements needed to calculate the specific capacity. Now, first of all, I'm going to rearrange this equation here. So specific capacity is equal to energy over mass multiplied by the change in temperature. Now, what are the things that you need? So there are three things that you need. So first of all, we need one, energy. Okay, so we need to measure the energy. Okay, so measure energy. This is the first one. Okay, so we need to work out the measurement of the energy supply. So measure energy supply. Okay, now this is the first one. Now what's the second one? We need to measure the mass of the waters. Okay, so measure mass of water. Okay, and then we need to work out what? We need to work out the temperature change. Okay, so measure temperature change. Okay, now three things, but it's 4 marks. So therefore, the last mark we need to add is details. The last mark is detail. Now, how does the detail look like? So the detail look like the following. So we're going to. So how can we measure the energy supply? So this we're going to do. Right. So pretty much use a joule meter. Okay. So this is how we're going to use the joule meter. Okay. Now, how are we going to take? How are we going to take? How are you going? Sorry. How are we going to take the change in temperature? So we're going to measure temp start and final. Okay. Okay. Then find difference. Okay. And this is how we're going to work this out. Alright. That's how we're going to work this out. Now for the measurement of the mass. Now the proper way to work the mass is pretty much you've got the cup. So what you can do if you have the scale, okay. Now what you can do, there's two things you can do. You can measure, you can put the cup first, okay. You can measure the mass of the cup. So this will be the mass of the cup. Okay, and then you can add water. This will give you the mass of the cup and the water, and then you can just take away first of all. So what we're going to do is we're going to do the following. So this one we're going to add. Okay, measure mass of cup. Okay, plus mass of cup plus water. Okay, now asterisk or in here, find difference. Okay, so this is extra to get just those 4 points. Now the next one is here. Say 2 ways to improve this procedure. Okay. Now, what can we do to this experiment to make sure it is secured? Now we're going to zoom in. Now what are we doing here is we are heating up the water. Okay. So the heat from the heater is going to go into the water. Now, what about here then? Okay, are we heating up any water? No, we're not heating up the water. So here we're heating up the air. We're going to go backwards. We're going to scroll down. We're going to add our points here. And this is the first points. First point would be the following. Okay, we're going to say fully merged the heater. So this ensures that all the heat is transferred to the water. That's one. And the second one is, okay, if I zoom in again, okay, let me just scroll down quickly. And look at that. So the heat can go into this space, it can also go up. So there's nothing protecting it up. Also, once the water is heated up, the heat can easily leave the water, so therefore there's no protection in this case. So this is what are we are going to add for our second point. The second point will be the following. We're going to add a lid, okay, or what we can do is we can also add insulation. Now, it's 2 marks, so this is 1, this is 2, this is 3. Okay, so any 2 of these points will give you your score. Okay. Now, energy we know, you just need to use the equation. We've got the mass, we've got the height, gravity is 10. Now, kinetic energy, people understand, so kinetic energy is half mv squared. So this needs to be squared. So the mass we know already. Done. And this one is you're reading it from the first bounce. So this is the first bounce. Okay, so anywhere between this point and this point. So this is the answer. Okay, anywhere between this point. Now, why does it not bounce back all the way up? So there's something going on, and it doesn't bounce back all the way. The question is why? Why is it not bouncing back all the way? Okay, so at the start here, at a certain height, it's going to have gravitational potential energy. Now, as this moves down, it's going to turn into kinetic energy. Now, as it bounces here, some of it is going to turn into sound and heat, and since it's going back up again, it has kinetic energy. Why is it not going all the way up? Okay, why is it not going all the way up? Okay, and this kinetic energy also going to change into GB because it is going up. Why is it not going all the way up? That's the question. Now, the reason why it is not going up is because of this here, because we have energy as lost. The way we want to structure this is the following. Okay, so get ready. So we're going to say the following. So energy has been lost. Okay. Now, lost house is lost to the surroundings. How has it lost the surrounding? It has lost the surroundings as thermal and sound. Okay, so that's how we get our 2 points. Okay, so this is the proper version of it. Now this is the calculations. Okay, now I'm just going to do the calculation here. So work done is force and distance. We're looking for the distance moved. The distance is work done over force. The force we know. This the work done. This is the energy. So work done is energy. So E over F. So this is E, and then you're done. Now it says SF. So you need to say, look how many SF we have. Okay, so 1, 2, 3, 1, 2, 3. So therefore the SF is going to be 3. Okay, so 3 SF. Okay, next one is this one here. Now, frequency is what? So frequency, you got one more thing. Frequency is the number of waves, okay, per time taken. counting the waves, so here the waves, you need to count them, count at a point, and the time using a stopwatch. Okay, so you're saying how, describe how am I determining the frequency? Yes, the frequency is number of waves over time. Okay, now how can I get the number of waves? I just count them at a point, and then how do I get the time? Is I use a stopwatch in this case. Okay, now wavelength. Now let's take a look at this one. So to work out the wavelength, we're going to use this one. We know that from one ripples to the next, this is one wavelength. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah, let's do 19. Okay. So what we have is so we're going to write down one ripple to next equal to one wavelength. Okay. Therefore, we counted there are 19 wavelengths. So this is one wavelength. Okay, and this roughly equals to 80 centimeters. So one wavelength is 19, and this will give you roughly 4. And the answer will be 4 in this case. Okay. Now, the students use the image to estimate the speed of the sound as this much. Why is not correct? Now, where is the wave? So this is the wave, water wave, and this is the screen. Now, what's happening? Look at the space. Look at the space. It has gone up. So what happened is the screen has magnified it. So this is the answer. Okay, so the wave has been magnified because how do we know? It's look at the size. Look at the size of look at those waves. Look how small the wave is. And look at the screen. It's been magnified. Okay. Now I'm going to show you the other questions in bits. So this is before. We're going to skip this one. Now this is already there. This one. So this one, people neutral the equation. Force is pressure times area. Okay. Now this one here. Just explain how force on small cabin from large cabin. Now we got the equation, which is force equal to pressure times area. Now situation 1 is the area is what? The area is small. So if the area is small, what happened to the force? The question says what happened to the force. Therefore, force is also small. Okay. So when the area is small, pressure is small. So therefore, force is small on small window. Okay. Now number 2, if A is large, then force is also large. Look, because A and F, they are the same. If A increases, then F will also increase. It's also large on large window. Now, what is the thing that is staying the same in both of them? So the thing that's staying the same in both of them is the pressure. The pressure is constant. Now, why is this constant? Because the question says the only thing that's changing is the window, which is the area, and how is the area affecting the force. Therefore, if two things are changing, then the third thing needs to stay the same. And this is how you're going to get to 2 marks. Now here, you need to draw an arrow. So, outwards, 90 degrees. And this is the resultant. Now, we need to show this one at X. And we need to show it is 90 degrees to the surface. That's 2 points. This one was fine. Okay, now remember, small gears. Okay, so they rotate faster. So if they rotate faster, now if the large gear is turning twice, then the the small gear will go faster. So the way we're going to do that will be the following. Okay, so we have the big gear, the big cog connected to the small cog. So this is 48. It's to 12. So pick out 1 is to 4. Okay. Right. So 4 times, therefore this rotates 4 times. So therefore, if large turns 2 times and small turns times 4, therefore 2 times 4 is 8 times. Okay, how we get it. Now this one is we want to be able to get all the points here. We need to talk about efficiency. Now first of all, oil. What does it do? Oil, it provides lubrication. Now, what does it do? It reduces friction. That's what it does. It reduces friction. Okay, so this is one. It reduces friction. Now, since it reduces friction, what does it do? Okay, it means that we have more useful energy available, and then it means that we have less waste energy. Okay, so this is the second point. Now since since we have more useful energy, okay, so we know efficiency is useful over total. But since we have, so therefore, more useful energy equal to more efficiency. Okay, because of this equation here. And this is for our 3 points. Now this question here, unfortunately, some people got this wrong. Let's see how we can do this. Now first of all, this worked because the total anti-clockwise moments equal to total clockwise moments. Okay, so we have force and distance, force and distance. Let's go back up. What we have is we have 600 times 0.5 equal to 1800 times equal to 2. Okay, now half of this is 300. The unit is Newton meter. Okay, this one is 0 meter. Now what we see is okay, we see that okay, the moment of rock is greater than moment of person, and this is why the person cannot lift it, because the moment, it is the moment. Now what is the moment? Moment, okay, is the turning effect. It is turning effect of a force. Okay, so this is the 3 points. You got 1, 2, 3. So this is what you need. So this section here. It is the moment, yeah? You can understand. Now, what can we do in this case? Now we know that moment is force and distance. Now, so all we want to do is we know that the moment here, this moment, is 300 Newton meter. But to increase the moment, we can increase this force here. We can make this force bigger, so we can increase this to maybe twice if you want, or we just make this longer, and therefore the girl is now here. This. Okay, so this is what we're going to do. We're going to say increase the distance person and pivot. Now, where is the pivot in this case? This is the pivot. There you go, this is the pivot. So you want to increase the distance from the person pivot. Now, in doing so, okay, all right. So in doing so, okay, this increase the moment of the person. So we have the equation now, which is force. Okay? So if the distance increases, therefore the moment increases. And this is the 2 points for that. Now the mass is there anyway. We are now going to be looking at the question that we left out. Now all this, everything else that we missed is in the equation, is the mass scheme. So do check the mass scheme that I have uploaded. Make sure all the above benefits been popularized. Okay. Alright, so now I'm going to pause the video,